This is LeetCode problem 424, longest repeating character replacement. You are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Before we try to find the length of the longest substring containing the same letter, let's first determine the most efficient way to make a string uniform with the fewest character replacements, which is replacing all characters except the most frequent one. If we know the highest frequency of a character in a substring, we can determine if our value of k is sufficient to make that substring uniform. Number of characters to replace is equal to length of substring minus the highest frequency. If number of characters to replace is less than or equal to k, then the substring can be made uniform. But if it is greater than k, then the substring cannot be made uniform. To know the value of highest frequency, we can use a hash map to track the frequency of each character. How to identify the longest uniform substring? We can use dynamic sliding window technique. We find the longest substring satisfies number of characters to replace less than or equal to k. If the condition is met, then we expand window to find a longer window that still meets the condition. If condition is violated, then we slide the window. When we find a valid window of a certain length, no shorter window will provide a longer uniform substring. This means we can just slide window instead of shrinking it whenever we encounter an invalid window. Now let's look at the coding part. We initiate an empty frequency hash map. Set highest frequency as 0, max length as 0. Both left and right pointer are at the start of the string. Before right pointer reach the end of the string, we update the frequency of the character at the right pointer and the highest frequency for the current window. We also need to calculate replacements needed for the current window. If number of characters to replace is greater than k, then we need to slide the window. We remove the character at the left pointer from the hash map before advancing the left pointer. The right pointer always gets advanced, so we just need to advance left. Since the length of the current window increases or stays the same, then we assign the length of the current window to max length. From there, we expand the window. Eventually, we return the max length. Time complexity is O of n, space complexity is O of m.